Welcome to Christ opencourseware. Today we will be continuing with the operations in linked list, and in this session I will be dealing with deletion in linked list. In previous videos we have seen insertion. Insertion takes place in three places: at the front, at the end, and at any other position. Similarly, deletion also takes place in three places: at the front, at the end, at any other position in a linked list. Before going to the deletion algorithm, we have to see another algorithm which is named return node. What is return node algorithm used for? In previous video, I have told you that in dynamic data structures, we have a memory manager. In memory manager, what does memory manager do in case of deletion? The memory manager has to collect the unused nodes in the memory, and it should be recollected to the memory pool of storage. So it can be used for some other purpose, right? So what does memory manager do? The memory manager takes the role of a garbage collector. It collects all the unused nodes in the memory and takes it to the memory storage pool. So this purpose is done with the help of the return node algorithm. Now let's look at the algorithm. Before going for the algorithm, what is in this figure has been shown in the previous videos. You have an avail pointer here. Avail pointer points to the memory pool of storage, and these are all empty nodes which are already present in the memory, and we use these nodes for linked list, which by using the get node algorithms. Now we will be using return node algorithm. So what happens here is the new node or the used nodes which are deleted nodes will be given back to the memory, and they are attached at the end of this available pool of memory, right? So this is available pool of memory, present available pool of memory, and the node which I am going to delete will be attached at the end of this nodes. So what happens here? Let's look at the algorithm. Avail is the header node of the memory manager. Memory. So the avail is a header node, and that is given to the another variable known as ptr1. Okay. Now we have to traverse till the end of the memory. So what will be the code? Until the ptr link part is null, we have to go forward. So that can be put in a while loop. So until ptr1 of link is not equal to null, you can go forward. That is, ptr1 is equal to ptr of link. It goes forward, and this condition goes until you find the link part as null. Next, after the while loop, what happens? Now the algorithm has reached the last node, and this is a node with link part as null. So what happens here? To this link part, we have to give the address of the node which we are going to return to the memory. Suppose let that node be this, and its name is ptr. So what I am going to do is I am going to return this node here, right? So the name of this node is ptr. Presently it does not have any address in its link part, so that will be null. Now this ptr node is going to be returned to the memory. So what happens? What I have to do? This is the last node in the memory pool, and that node is known as ptr1. So in the ptr link part of ptr1, I should give the address of ptr. That is, ptr1 of link is equal to ptr, and ptr of link equal to null. So by these two steps, what happens? The returning node is returned to the deleted node is returned to the memory, right? So I repeat, return node algorithms are used in deletion algorithms. Deletion can be done at front, at end, and any other position. Wherever deletion is done, the unused nodes are returned to the memory using the return node. So when they are returned to the memory, what happens is they go at the end of the memory pool and gets joined there, and these nodes can be further reused. Thank you. Now we will be dealing with the deletion algorithms, deleting the first node, that is from the front, and then after that we will be deleting node from the last, that is deleting the end node, right? So first we will deal with the front node. So what happens when you are deleting a front node? Suppose let the front node be known as ptr. So where do we get the address of PTR? That is the first node. First node address is always kept by the header node. Header node's link part holds the address of the first node, right? So we get the address of the first node. Now the link part of the first node holds the address of the second node. Let that be PTR1. So after deletion, what happens? After deleting the first node in the linked list, now the second node becomes the first node, right? So naturally the header node should be pointing to the second node. Okay, now let's see the algorithm. What happens here? We'll start from the header node. Let header link part is equal to PTR. That's what I have said. The link part of header is given PTR. That is, now we are pointing to the first node. So that is the value PTR. Now before deleting, we have to check whether the linked list is empty or not. So we have to check whether PTR is equal to null. That is, whether the link part of header node had a value null. If it is null, that means the link part is the linked list is empty. So if it is empty, we have to print a message and we have to exit from the algorithm. Else we go for the else part. Now what is happening in the else part? PTR1 is equal to PTR of link. Now as I have said before, PTR is the value of the address of the first node. So in the link part of PTR, what do we have? We have the address of the second node, and I give it a name as PTR1, right? So PTR1 will be the second node of the existing linked list. Now next, what should I do? I should give the link part of header node the value of PTR1. So what happens here? Now the header node will be pointing to the second node, that is PTR1. So header link is equal to PTR1. That means header node now will be pointing to the second node, and I can safely return this node, that is the first node, which is called PTR, using the return node algorithm. Okay, so and with this the algorithm ends. So what happened here is, first I give a variable name, a pointer variable name to the first node to denote the address of the first node, and I got it from the link part of the header node. Now from the link part of the first node, I get the address of the second node, that is the PTR1, and I give it to the link part of header. So now header node will be pointing to the second node, right? Now what can I do? I can safely return the PTR node, that is the first node, to the memory bank using the return node algorithm, and hence the deletion from the first node, deletion of first node or from the friend is possible, right? With the same figure, I'll be explaining deletion at the end. Deletion at the end means what is happening here. Deletion at the end means you have to traverse all the way to the end of a present existing linked list. As we have seen in the algorithm of deletion from the friend, we are always to check whether the linked list is empty or not. So for that, we have to just check whether the link part of the header node is empty or null. If it has the value of null, that means the linked list is empty and we have to exit from the program. So here also, otherwise what happens? In this given example, you have a 4 node linked list. You have to traverse till the end, because here I'm going to delete this particular node, that is a last node, right? Now what happens here? Else part, if part I have said, you start from the header. If the list is link part is null, then that means the list is empty. You have to exit. Now what happens here? The else part, what happens? You have to traverse till the end. So for that we use the while loop, and while traversing I have to keep track of the before node. That is, suppose I start with the first node, then I have to keep record of the header node. Then when I am reaching the second node, I have to keep record of the first node. When I reach the third node, I have to keep record of the second node. And now I have reached my last node. I have 4 nodes in the given example. So when I reach here, and this is tracked by the variable PTR. So I have to keep record of the previous node, and that I give name as PTR1. Why the previous node is important here? Because the address, because now the previous node becomes the last node. So what happens here is that, and that is done with the help of PTR1. So when you give, when you go forward in the while loop, PTR is before incrementing the value of PTR, it is given to another variable PTR1. Okay, so PTR1 is equal to PTR, and then you go forward for the next node. So after that, what happens here? Naturally, you are going to delete this node. Now what this, you can keep the link part of PTR1 as null, and you can return safely the last node, this PTR node, to memory with the help of the algorithm return node. So repeating, while going forward, you have to keep track of the previous node, and that is done with the help of the statement PTR1 equal to PTR, and then you increment PTR equal to PTR of link. Okay, so now PTR will be pointing to the next coming node, and at last when you reach the last node of the linked list, the last node will be referred as PTR and the previous node will be referred as PTR1. Now what we have to do is, since you are deleting the last node, all we have to do is you have to keep the linked list link part of the previous node as null, return node PTR to memory using the return node procedure, and deletion at the end of linked list is completed. Next we will be dealing in the delete at any position algorithm. Now what happens when you delete at any position? So in this case you will be dealing with you are deleting a particular node or a particular data, and then at that case you have to specify what data you are going to delete. Suppose in this example, let's take data or the key that we are going to delete will be 4. So the node which has a value 4 should be deleted from the linked list, and we don't know what is the position of data 4 in the linked list. Okay, so this is the position of 4. Now what happens when you have to search for the value key, the key value in the linked list, that is 4. So starting from the header node, you start and you traverse through the linked list. At the same time you check whether the data part is having the value, the key value, that is 4. So when you reach this particular value or this particular node, what happens is, from the link part of this node you get the address of the next node, and that value should be given to the previous node link part, right? So suppose this is the node and let it be PTR. So the previous node can be named as PTR1. Now PTR1, link part of PTR1 will have the value of PTR link, right? So if this node is PTR, the link part value now is belonging to the link part of PTR1. Now let's go to algorithm. We'll start from the header node. In the header node, the value of the header node will be given to the value variable PTR1, and now PTR1 of link is equal to PTR. That is, we for traversing we use the variable PTR. Now until PTR is null, you have to go forward. Now we have to check with the data part, the key value, check whether PTR data part of the node is having the value key. That is, in our example we have to check whether the key is 4. So until it is not equal to key, you should go forward. So while going forward, as I said in the before algorithm, you have to also keep track of the previous node. So when the data part is not equal to the key value, you give the value of PTR to PTR1. So first, when you're if this is PTR, and before it is incrementing, it is give also the same value of PTR is given to another variable PTR1, and then PTR is incremented using the statement PTR equal to PTR of link. So this goes until you get the data part as when the data part is not equal to the key value. Suppose the data part is equal to key value. So what happens here is, in our example, the while loop, the if condition will be checked 2 times, right? So first time data is not equal, so it goes forward. This will be PTR1 and this will be PTR. Now when it again come to this, here it stops. The if condition will not work here, so we will go for the else part. So in else part, what we will be doing, we have to give the link part of PTR value, PTR link part value to PTR1. That is, the node of the address of the next node, next successor node of the PTR now should be held by the previous node of PTR. So that statement is done here. You give the value PTR link to PTR1 of link. That is, if this node is PTR, the successor address will be present in the link part of PTR, right? So, and now that will be given to the link part of PTR1, and you can safely return the PTR node to the memory bank using return node algorithm, and you can exit from the program. So return node algorithm is used here to exit PTR to give it to the memory bank. And this will be the last algorithm of deletion. We have seen algorithm of deleting from the front, deleting at the end, and now deleting at any position. Only in this algorithm you give a particularity to the key value. According to the key value, you search for the key value, and that particular node is deleted.